Thank you, everyone, for joining us. We're going to give about 60 more seconds for everyone to come into the room and join us for this webinar. We'd like to lead with the reminder that this webinar is recorded. The recording will be made available to all of you shortly after the event and will be posted on our website so you can share with your friends and colleagues. Additionally, any questions, please put them in the chat and we will answer them at the end of the presentation. With that, I would like to thank you for joining us this lovely morning, afternoon. It is 9 o'clock here on the East Coast of the United States. It is 4 p.m. in Kuwait, where our distinguished OT cybersecurity Mohammed awaits to give you the presentation. I am Brian Mitchell. I lead marketing here at Industrial Defender. We are an OT cybersecurity software solution provider with more than 20 years experience serving the OT ICS community with best-in-class deep asset visibility, change management, change visibility. This is the one in a series of webinars that we have produced throughout Europe, the Middle East, Africa, in order to educate our audiences on the shifting world of OT cybersecurity and how it relates to your work. Mohammed comes to us with decades of experience in OT cybersecurity. He has close relationships with many of the actual practitioners across the Middle East and Africa, and has spent a considerable amount of time translating the Kuwait Directive into a presentation that can help you be more informed on how to apply it to your organization. Most importantly, for those of you who aren't in Kuwait, please remember that their framework is based around compliance, and compliance in Kuwait will help anyone, anywhere, whether they're in Saudi, Jordan, Bahrain, Morocco, Kenya, South Africa, all the places we've had people register for this webinar. It will help all of you provide better cybersecurity if you are able to map to this compliance framework. With that said, I will turn it over to my esteemed colleague, Mohammed, in order to share his expertise on the Kuwaiti cybersecurity controls and how it relates to your ability to be more compliant and protect your critical infrastructure. Mohammed.
Thank you, Brian. Thank you. Assalamu alaikum. Good morning, good afternoon, everyone, and thank you for joining today's session. I am Mohammed Dabour, Solution Engineering Director at Industrial Defender. Today's session focused on how organizations in Kuwait can approach OT cybersecurity compliance in a technical way, especially in critical infrastructure environments such as oil and gas, petrochemical, and utilities. The purpose of this webinar is not to treat compliance as a documentation exercise or a one-time audit activity. Instead, we will look at how compliance requirements translated into operational capabilities like asset visibility, configuration evidence, recovery readiness, and governance reporting. We will also discuss where technical OT platforms such as Industrial Defender fits into the overall evidence architecture. The focus is especially on its role in supporting OT visibility, monitoring, evidence collection, and integration with enterprise systems such as the SIEM platform and remediation workflows. It's very important to clarify that from the beginning, no single platform creates full compliance by itself. Full compliance required a combination of technical controls, governance ownership, operational procedures, and continuous review. So the main The main theme, I will call it, so the main theme today is to build a reliable OT evidence and monitoring foundation first, and then use that foundation to close control gaps, support investigation, and sustain compliance over time. With that context, let us start by defining the major problem that organizations are trying to solve nowadays for the OT environments. Organizations today are facing three major pressures. The first pressure, which is the cyber threats, are growing, especially on GCC, considering the latest geopolitical tension. So attack surfaces are expanding. OT environments are becoming more more connected and becoming more targeted because of this connectivity. And the second pressure that many organizations till today still suffer from lack of visibility across the OT asset network and environment. Considering that an OT environment assets are not limited to workstation or servers, we have in the OT networks PLCs, RTUs, safety system, field instrument, and even sometimes unmanaged or legacy systems. Without unified visibility, it becomes difficult to know what exists, what is vulnerable, what changed, and what evidence is available during an audit or incident. The third pressure or the third pain, meeting compliance requirement can become cumbersome and manual process. Teams, which lead teams, often spend significant time collecting spreadsheet, screenshots, asset list, other log export, policy evidence, and this slows down audit readiness and delays remediation. So the key need here is clear. Organization need unified OT visibility, stronger monitoring, and faster compliance evidence generation. This is where we're gonna see later on how we can do it with our platform. Before we go deeper, it's useful to clarify three terms that are often used together: framework, standards, and regulation. A framework helps us organize the program. Its answer usually the question, how do we structure cybersecurity risk management? As an example, a framework helps us define domains, ownership, priorities, and maturity, where the standard help us understand how controls should be implemented, and usually it answers the question, how should controls be designed, operated, and validated? Standards give us a common control language and a technical expectation. And finally, regulation defines what is mandatory, and it is the main answer to a question, what must be proven to regulators and authorities. So regulation define obligation, expectation, and sometimes enforcement requirement or consequences. The practical view, it will be like this. The framework starts with organizing the program, the cybersecurity program, and the standard will define the control implementation, and the regulation establish what need to be proven to the regulator. For Kuwait, this distinction matters organization because organizations need to align global good practice with local regulation expectation. Now let's zoom out to a regional level. OT cybersecurity programs across GCC or Middle East align with multiple references at the same time. These may include NIST CSF, NERCSIB, IEC 62443, and maybe also a sector-specific regulation. The challenge is that every country, every site, and every business unit creates its own separate control mapping. The compliance program becomes fragmented. The better approach is to build one common OT control library and OT evidence backbone, and then apply multiple of compliance regulation standards to it. For example, the OT segmentation maps to the NIST Protect and Detect, in the same time to the IEC 62443 zones and conduits, in the same time with the Saudi regulation, the OTCC, it's mapped to the architecture separation. The key message here is align once, localize many times. This means we can build an OT security baseline, then overlay, for example, here, Kuwait NCSC or other global standard requirement without reinventing the control model every time. Before we discuss any control mapping, we need to establish structure of the Kuwait NCSC control model. The Kuwait National Basic Cybersecurity Controls are organized on 6 cybersecurity functions or domain: govern, identify, protect, detect, respond, and recover. And this structure is useful because it separates cybersecurity responsibilities into operational domains, rather than treating compliance as a single checklist. I will take an example in here for let's say the first domain, govern. This covers cybersecurity governance, ownership, policy management, risk acceptance, and also as an example, the accountability. From a technical program perspective, this domain defines who owns each control, who approves deviation, and how cybersecurity decisions are documented and reviewed. Now that we introduce the Kuwait NCSC control structure, the next step is to translate those control domains into a practical OT evidence requirement. The important point here is that compliance cannot be demonstrated only by saying that a control exists. For each NCSC function, the organization needs evidence that the control is owned, implemented, monitored, and maintained over time. So this slide breaks that down into three parts: the NCSC function, then the technical control intent, and then the required OT evidence. And let me take this time an example of identify. The identify domain. This is where organization proves it understands the OT environment. In technical terms, this means maintaining an accurate asset inventory of OT assets, software, firmware, and also the ownership, location, and even the criticality of that asset. Without this evidence, it becomes difficult to validate whether the rest of the controls are actually applied to the right systems or no. Oh, sorry. The main takeaway also from this slide that I would like to capture in here and share is that each NCSC domain needs a clear evidence model. So for the OT environment specifically, that evidence usually comes from asset inventory, configuration state, vulnerability status, log sources, and also monitoring outputs. And also even it goes to the governance records. So now, since that we understand what the evidence is required, we can look at where the strongest technical alignment exists and which control areas can be directly supported through OT visibility, monitoring, and evidence collection. We already in previous slide we mapped the NCSC function to the evidence requirements. The next question that we want to answer in here: where does the evidence actually come from? For OT environments, compliance evidence should not rely on manual spreadsheet or screenshot. It should come from a combination of a technical data sources, operational records, and governance artifacts. That can be, and most importantly, all of that must be must be collected, validated, and refreshed over time. So in this slide, the main evidence sources divided into 6 categories. And let me take as an example the second category, which is configuration and change state. This evidence shows whether systems remain aligned to approved baseline. As an example, secure configuration baseline, the open port like set by the operator or the engineer, the configuration drift, and the approved change record. This is important because many OT incidents begin with unauthorized or unmanaged changes. Again, the main takeaway from that is the NCSC compliance evidence should be built from both technical systems and operational processes. And for a mature OT compliance program, the objective is to normalize these different evidence sources into a repeatable model that supports audit activities, risk management, incident response, and continuous improvement. So once the evidence sources are clear, we can identify which areas are directly supported by the OT visibility and monitoring, and which areas still required complementary controls, such as governance, documentation, segmentation, identity access management, backup, and recovery solutions. A key point, since we identify the main OT evidence sources, is to define how we interrupt or interpret the control coverage. The key point again is that not every NCSC control is satisfied in the same way. So some controls can be evidenced directly from the OT system. Some of the controls depend on integration with the enterprise platform. Others required a separate enforcement technologies. Could be also architecture changes or governance processes. You establish a new policy as an example. Excuse me. So this slide, in this slide, we separate the coverage into three categories. As I said, the direct OT evidence, the indirect integration support, and complementary controls. I will speak here on the first category, which is the direct OT evidence. The direct OT evidence coverage. These are controls areas where evidence can be collected directly from the OT telemetry or system state. Example of that, asset inventory, software bill of material, and configuration baseline, and also event history and vulnerability status. From technical perspective, these controls depend on accurate and continuously maintain the OT data. The question that usually asked here is, can we prove the current state of the OT environment with reliable evidence or not? And then the second category, which is indirect integration support. In this category, the OT evidence supports the control, but another system or process completes the workflow. As an example, the SIEM integration or the SOC monitoring workflows, the GRC evidence tracking, and vulnerability remediation workflow. For these controls, OT data provides the context, but the final execution happens somewhere else. For example, OT monitoring tool may generate an event, but the SOC team is the one who will investigate on that event. And the third category, which is complementary controls, or the complementary controls required. These controls cannot be satisfied only through visibility or evidence collection. It required separate implementation. As an example, it could be network segmentation enforcement. It could be multi-factor authentication, backup and recovery testing, and it could be also the VAPT activity. From a technical compliance perspective, this group or this differentiation is important because monitoring can only show whether a control exists or whether activity is occurring, but it does not replace enforcement. As I said, for example, visibility can help you validate the segmentation, but the firewalls and architecture enforce the segmentation. The takeaway from this slide is that control coverage should be assessed by responsibilities for each NCSC requirement. We should ask the global or the main or the core three questions. Can this be evidenced directly from the OT systems? Does this require integration with an enterprise workflow or platform? Or does this require a separate control, process, or a technology to be implemented? And then you can map it to one of those group. So this approach prevents overestimating what visibility alone can achieve, while still recognizing where OT evidence provides strong value for compliance, risk management, and incident response. So using this coverage model, we can now identify which NC SC controls have the strongest direct alignment with the OT evidence and monitoring, and which areas need complementary controls to complete the compliance program. Yeah. So now that we have identified the NCSC control structure, the OT evidence requirement, and the control coverage model, we can identify the NCSC controls where the technical OT evidence provide the strongest direct support. So these controls are not a policy driven. They depend heavily on reliable asset data, system state, configuration information, and vulnerability visibility, and also log collection. As an example, I will take in here the fourth one, which is vulnerability and patch visibility. The vulnerability and patch visibility. This control requires visibility into vulnerabilities, patch gaps, and unsupported system and remediation status. So in the OT environment, vulnerability management must be a risk-based. So the evidence should show the CVEs by asset, and also missing patches and the software and firmware version being impacted, and also at the same time it should shows the end of life systems, and I highly recommend also to have the vendor advisories and remediation status, and also if possible the approved exceptions or changes on the patch or the vulnerability level. The objective is not only to identify vulnerabilities in here, but also prioritize them based on asset criticality, exposure, vendor support, and maintenance window limitation. So the main takeaway again from this slide is that these controls are evidence heavy, and it's required, or they required accurate OT data, and also continuous collection methods, and validated reporting functionality. So written policies are important, but they are not enough to cover all the evidence required by the regulation. So the organization must be able to prove the current state of the OT environment, and in the same time they have to show the evidence that can be refreshed, reviewed, and used operationally. So moving forward, since now we have identified where the strongest technical alignment exists, we will go to the next question, is how this evidence is collected, maintained, and integrated into broader OT compliance operating model. So this slide introduces Industrial Defender from a technical perspective. the role here is not to replace or to replace the full compliance program. Instead, Industrial Defender fits into the OT evidence architecture as a platform that can collect, normalize, and maintain OT evidence for security operation, compliance team, and remediation workflow. So, as this slide shows, there is 3 stages or technical stages. The first stage is the OT data inputs or the OT data collection. This include raw data collected from the OT environment from multiple of resources like the asset inventory, the software, the configuration, vulnerabilities, and even the traffic metadata. The important point is that evidence quality depends on the collection scope and the data source coverage. And also, again, I'm repeating that again and again, the collection frequency. If the collection scope is incomplete, then the compliance evidence will also be incomplete. So once we're done with OT data collection or the OT data input, the second stage started, which is the evidence processing. At this stage, the data is normalized, baselined, correlated, time-stamped, and maintained over time. This is where raw OT data becomes useful or useful evidence or valuable information. For example, configuration data becomes a baseline, change data becomes event history, as an example. So you can consider that as a processing layer, which is honestly, it is very important because compliance evidence needs to be repeatable, historical, and also reviewable by multiple of team in the OT environment. And again, it should not depend only on manual screenshot or one-time export or collection. Then we reach to the last stage, which is the technical output. The technical output or these outputs include control evidence, investigation context, SIEM integration, and also audit-ready records. This stage where OT evidence become useful to the broader organization. Security operation can use it for monitoring and detection. Compliance team can use it for control evidence, and remediation teams can use it for prioritizing and tracking the closure. And also, if the organization have a governance and risk team, they can use it for reporting and monitoring the anomalies or exceptions or the change management within the OT environment. The key message that I want to take or get out from this slide is that evidence and monitoring function this three functionalities or stage is an evidence and monitoring function. And this is where actually Industrial Defender platform, as an example, can help provide visibility, monitoring data, and evidence context that can be used for the auditing or compliance matters. So now that we understand the technical role of the platform, the next step is to look at how this evidence is collected in a safe way from different layers in the Purdue model. In the OT environment, data collection must respect segmentation, safety, and availability requirement of the OT network. And the Purdue model helps organize the environment into those level to match those requirements, from enterprise system at the top down to the devices, the field devices, sorry, and control system at the bottom. From technical design point of view, evidence collection should avoid introducing unnecessarily inbound access into those sensitive OT environment and networks. So collection methods may include passive monitoring, agentless, or if it is applicable or allowed, the agent, and also and sometimes it's not an automatic collection. In some system or like sensitive system or legacy system or even air gap system, it could be a manual collection for the data from those specific or special devices or network. The approach in here to support visibility while respecting segmentation, operational risk, and the safety sensitivity of the OT environment. So once the evidence is collected from the OT, the OT devices in different level in the Purdue model, it becomes more useful when we integrate into the enterprise security platform and governance system. So in here, actually, I always say OT evidence should not remain isolated. So that being said, that most organizations already have enterprise system for security operation or asset management or governance. So the goal is to feed the OT context into those systems so the enterprise workflow include an accurate detail or an accurate OT data. As an example, I will take for the SIEM because most of you are familiar with that one. The OT logs and alerts provided or provide event visibility and correlation with the enterprise security events. So, and for the SOC team or the SOC operation, the asset context helps the analyst understand whether an alert affects a critical system and what process area is involved on that event or that incident, and what operational impact might be happened or occurred because of that incident. And the key technical point here is the integration does not mean all systems do the same job. Each system has different role, and the OT evidence provides context to multiple enterprise platform that can execute that workflow and provide the end user with the ultimate benefit. So even as a conclusion, even with strong OT evidence and integration, some NCSC controls still require a separate implementation that is focus, or it will be our focus in the next slide. So in this slide, highlights the areas where visibility and evidence are not enough. Some control must be implemented through dedicated technologies or architecture or a new governance policy or operational procedure. And I will take as an example the EDR, the endpoint protection. The endpoint protection or whitelisting in OT monitoring, or the OT monitoring tool can receive events from endpoint tool, but malware prevention or the application control or the EDR function require dedicated endpoint software or application, and it must be again suitable for the OT system and subject to the approval from the OEM of that OT system. The main takeaway from that slide, that the technical visibility is something necessarily, but it is not sufficient by itself. A complete compliance program needs OT evidence, enterprise integration, in the same time enforcement controls and governance ownership. So with this or that being said, we can now move from evidence architecture into the implementation roadmap. So what should be done first? What should be integrated next? And how we close the remaining control gaps over time. So the NCSC on their cybersecurity minimal controls or baseline, they put a timeline of 18 months. So with the evidence architecture and control coverage model defined, the next step is execution. And the key question in here, what should be done first? What should be integrated next? And as I said, how do we close the remaining control gaps over time? So this roadmap structured on or proposed or suggested to be in 4 phases over the 18-month maturity path. The first month, which is a duration of 3 months, where you need to establish the baseline. The first, which is basically as it is should be, the first phase is about baselining or building the foundation before implementing advanced controls or advanced processes. The organization needs to define the OT scope, assign control ownership, and also validate the OT asset inventory. The goal from that phase is to answer like around 4 to 5 questions, which is what OT environment are in scope, who owns each control, which assets are critical, what evidence already exists, and what evidence is missing. Which system should provide logs or monitoring data. So at this stage, the focus is not to full control maturity, but the focus is creating a reliable baseline for decision making. And then moving to the phase 2, which is also again 3 months period, which is all about integration. So in the phase one, the OT evidence sources are identified, and we move to the phase two, where to connect that evidence into enterprise workflow or enterprise platform. This include again the SIEM platform, or integrate with the SOC operation solutions and platforms. It could also include integrating with the CMDP and vulnerability management tool. The objective of that phase is to avoid isolating the OT visibility. So the OT evidence should support existing security and compliance platforms and solutions. Moving to the phase 3, again, it is, and this time 6-month period or duration. In this phase, the organization should have enough visibility to identify the highest risk gaps. Common priority area include, for example, segmentation, multi-factor authentication, remote access management, and other remediation discipline or solutions. This phase is important because visibility alone does not enforce controls. The organization or the operator must know or must move in that state from knowing the risk to reducing the risk on that stage. And control closure should be the control closure should be risk-based with the priority given to a the critical asset within the OT environment. And then moving to the last phase, which is sustained resilience. This fourth phase is all about organization to validate the backup and restore capability, review open changes or exceptions, and maintain audit-ready evidence. The objective on the last stage, not only to pass a compliance review or an audit, the objective is to make the control environment sustainable and resilient. The main takeaway or the main message that we want to deliver in here or from this roadmap is that the OT compliance maturity should be built in a sequence. First, establish visibility and evidence ownership. Second, integrate OT evidence into enterprise workflow. And third, close the priority control gaps. And then finally, sustain the program. After defining that roadmap, the next step to look at the execution responsibilities. Which activities belong to which team on the organization? The operation team, which is the OT team, or the cybersecurity team, or the IT, the enterprise IT team, or the risk and governance team. So after defining the implementation roadmap, the next step is to clarify execution responsibilities. So a roadmap only becomes actionable when each activity has a clear owner. In OT compliance programs, responsibility is usually shared across 4 groups: operation, cybersecurity, enterprise, the enterprise IT team, and risk and governance team. Starting from the OT or the operation team. Why we involve them? Because they are the closest people to the production environment. and they are the one who should own the asset context, the site knowledge, the maintenance window planning, and operational impact assessment. And they are the one who understand which systems are critical, which changes are safe, and when changes can be implemented without affecting production or the safety of the environment. And the second group, which is the cybersecurity group, they owns monitoring and detection and also managing the vulnerability, and also they are responsible to the risk, the cyber risk tracking. This team, they should define the security standard for example, for remote access, for incident response, for vulnerability management. Cybersecurity team should not make the OT changes independently, but should provide the risk view, the monitoring requirement, and control the validation criteria. The third group, which is the enterprise IT group, is the group who's responsible for connecting the OT evidence into a broader enterprise system and platforms. This include, for example, the SIEM solution, the SOC platforms, the PAM and IAM systems. As an example, just to understand that, the OT logs may need to be forwarded to the SIEM. So the asset data may need to enrich the SIEM, the CMDB. And also the vulnerability findings may need to create tickets for remediation tracking. So the enterprise IT team helps with data normalization, integration reliability, and also making sure the communication infrastructure are running within the environment. The fourth group, which is the governance and risk group, they are responsible for policy oversight, compliance coordination, evidence list ownership, and remediation tracking. This group within the organization makes sure that the program is not only technically active, but also auditable, repeatable, and aligned with the compliance expectation. So the key message in here that no single team can own the full OT compliance life cycle alone, and the OT or the operation team provide the operational context, the cybersecurity team provide the risk and monitoring leadership, and the enterprise IT provide the support for integration and connectivity, and the governance, risk and governance team provide the oversight, evidence discipline, and reporting to the management. So the main takeaway, clear ownership reduce control gaps and turns OT evidence into sustained compliance execution. So now the ownership model is clear. So we can move to controls that required coordinated execution across these 3 or 4 teams, sorry. And as we can see, especially segmentation and remote access, vulnerability and patch governance, and the other three areas. Let me take the 5th area, which is the 5th work stream, which is incident response and reporting. This work stream defines how OT incidents are triggered, escalated, investigated, and reported. It should include technical evidence collection and clear communication path. Expected output include incident playbooks, contact matrix, event timelines, and investigation notes and reporting templates. The key takeaway from this slide is that control closure required coordinated execution, and the OT or the operational team validates the operational impact. In the same time, the cybersecurity team define risk and have the ownership to monitor and the investigation or the incident response requirement. And while the enterprise IT team is still owning the enterprise infrastructure and also the communication or connectivity infrastructure. While governance, basically, they are owning the evidence, accountability, and reporting. After defining these work streams, the next step is to validate the readiness before the alignment deadline. So, after defining the execution work stream, the final step is to validate readiness before the alignment deadline, which is after 18 months since the publishing the alignment on the newspaper in Kuwait. The key point is the readiness should not be measured only by existence of policies or documentation. It should be proven through repeatable evidence, assigned ownership, and control execution that can be demonstrated continuously. So this slide demonstrates the readiness checkpoint, starting from the first checkpoint, the OT visibility, where the organization should be able to confirm the visibility on the OT asset, and then starting with the second checkpoint, monitoring coverage, where the organization need to demonstrate that they are prioritizing the OT logs and events, and show that all of these logs and events being collected, retained, and reviewed. And also the third one, which is control closure, where they need to demonstrate that the high-risk gaps should be tracked and actively remediated. The fourth checkpoint is audit evidence. The organization should be able to produce evidence in a frequent manner without relying on manual rework every time. This includes, for example, the evidence list or the evidence collection. The fifth checkpoint is incident readiness, where teams should be able to investigate, escalate, and report any OT incident using reliable evidence. The sixth checkpoint is recovery readiness, where the organization need to demonstrate that they can recover in a safe and sequence manner without any failure or without any gaps on the process. And the final one is the final checkpoint is governance review, where all exception, risk, KPIs, and remediation action should be reviewed in regular manner. So the main takeaway is that readiness is proven when controls can be reviewed, documented, repeated, and improved. And it is not enough to create documentation once. The organization must be able to show that the compliance process is operating continuously. Once these checkpoints are validated, organization can move from project execution into sustained compliance operation. And the final recommendation that I want to share with you in the end of this session is that please treat OT evidence as a technical foundation while completing the program through governance, enforcement controls, integration with the enterprise platform, and continuous review and ownership. So in the end, thank you very much for your time and participation, and we are more than happy to answer any questions. Brian?
Yes, can you hear me?
Yes, I can hear you.
Excellent. We had one question come in just recently asking about the way we collect the data on the assets.
Yeah.
Is it active, passive? How does that work for how we gain our our asset visibility?
So we are collecting with a mix, or I consider our tool like a Swiss knife, that you are able to use any of the tool in the Swiss knife based on the requirement of each, or the best way for each asset. So it combined with manual ingestion, with passive monitoring, where we are listening to the network and collecting the data, or with the active part, which is agent and agentless, whether it is on connected environment or on the isolated environment. And the final one, through integration with other tool and other platforms within the OT environment. So I hope that answered your question.
It does. And can you go a bit deeper in sharing any of the work we're currently doing in the Middle East to support clients?
Yes. So in Middle East, we are actually exist in the region since now 7 years ago. We exist in petrochemical industries heavily, oil and gas, and also utilities. And recently, we also exposed to the smart city sectors, where we are monitoring all of these OT system on the smart buildings, from HVAC system, building management system, and other smart systems.
And can you
Yeah.
talk about why people why clients use us in the BMS space, independent of any need for the kind of traditional cybersecurity we do in oil and gas?
Yeah, because of the kind of first, for example, building management system, they are a different type of OT systems. So the traditional IT system, they cannot give the right visibility to those systems. This is one. Secondly, why specifically, for example, from our platform? Because we have our way, which is the agentless, the safe way, or safe method to collect the data, the agentless, where we are gathering not only the, I will call it, static data of the asset, but also we monitor the changes, we monitor the configuration files, of those assets in the building management system. Yeah.
Excellent. I think that is all the questions we have for today.
Thank you very much, and thank you for attending with us today's session.
Thank you, Mohammed, and thank you everyone for joining us. Again, as a reminder, we will send the recording to all of our participants and have it on our website here by the end of the week. We look forward to connecting with you after the event and wish you the best in protecting your OT cyber assets. Thank you very much.
Thank you. Thank you.